Okay, so this particular note page is just a quick review of resultant vectors. So this is when we add up vectors. We did this when we added our displacement vectors. We did this with velocity vectors. So obviously the direction we're going is to force vectors. So here's what you need to remember. A resultant vector is really just the sum of two vectors, okay? Now the size of the vector, that's called the magnitude. So with respect to forces, okay, the larger the vector, the greater the amount of strength that we're applying to something. All right, so to find the resultant of two vectors, we have the x direction. So if we're moving left and right, we are generally going to go with right is the positive direction and left is the negative direction. All right, y, that's your up and down forces. Up's going to be positive, down is negative. And if we have two, so if we have unbalanced forces in both the x and the y, we would end up doing the Pythagorean theorem. We're not going to do a lot with this, so this is not going to be part of the review today, but I just wanted it here as a reference if it comes up later on. So first, for example 1, we have 8 meters left and 10 meters right. So we're going to go ahead and draw a picture of that. So if I do 8 meters to the left, I'm going to start here. So this is my start. And I'm going to go 8 meters to the left. Okay, now this is my current location. So I'm going to move down a little bit to give myself some space. But from here, I need to go 10 meters right. So then what happens is I end up with a resultant vector from the start to the end. So what happens is this is where I started, and this is where I end, and this is the resultant vector that I'm looking for, this blue guy, right? So the blue guy, that resultant, is what? How far is that? 2 meters in what direction? To the right. So this is a visual representation of what's going on, okay? Now, if we were to calculate this, we are always going to assume left and down are negative. So another way to do this is I could add negative 8 meters plus positive 10 meters because this is to the right. So when I add the two vectors together, I get positive 2 meters, which means that's 2 meters to the right. Okay, so this is just mathematically adding the vectors without having to draw this out and actually visualize the resultant vector. Okay. So for the next one, we have 3 vectors. So for this, let's take a look. We're going to go 2 meters up. So I'm going to start right here. I'm going to go 2 meters up. Okay, so this is my start. And then from here, I'm going to go another 7 meters up. Okay, and now this is where I'm at, so I'm going to go to the side a little bit because now I'm going to go down 13 meters. So my resultant vector, I'm always going from where I started to where I ended. So my resultant vector is right here. So what is that distance from here to here? How much? 4. It's going to be 4 meters in what direction? Going down. Okay. So this is taking a look at the vectors and seeing our start and end position and then looking at the size of what that resultant has to be. But obviously, it's much easier if you look at the directions just to add and subtract all the vectors. So for example, I have positive 2 meters. So this is my first vector. Plus, this is positive 7 meters. Plus, this one is negative 13 meters. Because now I'm going down. So here I end up with 2 plus 7 minus 13, and that's just going to be negative 4 meters, which means that I'm going down. Okay, so down 4 meters. So this is my preferred way, just to add them up. Okay, and then for the last example, Now we're talking about speed, but it works the same thing, velocity. This is my speed, 7 meters per second. It's velocity because it's going north. All right, so for this one, we'll have, we're going north, south, south. So let's go ahead and start up a little bit. So I'm going 7 meters north. And this is meters per second. 7 meters per second north. And then from here, so I'm going to move over, I'm going 5 meters per second south. And this is where I'm at. So this was my start. I'm here right now, and that's going to be another 8 meters per second south. So this is where I end. So if I'm looking at my resultant vector, I go from where I started to where I ended, and how much is that? 6 meters per second. So this is 6 meters per second south. So my velocity is 6 meters per second south. But again, much easier just to say, oh, all right, that's a positive 7 meters per second minus 5 meters per second minus 8 meters per second. So then you would get negative 6 meters per second, and the negative tells you that we must be moving in the southward direction.